Okay, good morning, guys. Good morning, JSS2. How you doing? Welcome back to school. I'm happy to see you guys again. I'm happy to have you guys watching this video again, rather. I hope you've been enjoying your holiday so far. Hope everything has been good for you. Okay, so once again, welcome to school. Welcome to today's math class. And in today's math class, we're going to be doing something very interesting. It's a topic that I started with you last week. Was it last week or this week? I think this week. Yeah, right. Linear graphs. Okay, so basically, before we begin class, I would like you all to say thank you to your teachers for working together to make sure that you learn a lot, and say thank you to the proprietor and proprietress for making this platform available for you. All right. Okay, so moving on. Today's math class, we're looking at graphs of linear equations. Graphs of linear equations. Graphs of linear equations. Okay. Last week we looked at linear graphs and their applications in real life cases, right? But they will be looking at linear equations now, not just linear equations, but the graphs of linear equations. I believe in the last class, you remember I taught you about these linear equations graphs, and then I explained a few things to you in the note. Remember, I explained to you that there are three things that we'll be touching: the general forms of linear equations, the equations and tables of values, right? And then how to plot the tables of value from the table of values, how to plot graphs on the table of values, right? And then last week and last class I taught you the general forms of linear equations, and then I taught you the equations and tables of values, right? And then this general forms of equation, if you remember, in the last class I told you that we in the notes, the general form of equation of a straight line is defined as y equals mx plus c. You see that m and c are constants in the equation, right? They don't change. They are not alphabetic. They are real numbers. Okay. So now m is the coefficient of x in this statement. Now let me get my pen. Okay, this is the equation, right? So we're told that m is the coefficient of x, right? And it is often called the gradient. I want you to underline this gradient. If you have not done it in your note, in the note you wrote, underline gradient. It is the gradient of the line. Okay, that's, make sure you underline it. All right, let me remove the remaining listen. So underline gradient. All right, so then the c there is called the intercept. Underline intercept. Also, it is called the intercept on the y-axis. The m is the sorry, m is the gradient, is the coefficient of x, is the number that is always beside x, while and it is also called the gradient of the line. But the your c is called the intercept. It's a constant that stands alone. Okay, so it's your intercept on the y-axis. That is the line that touches your y-axis. Okay, so moving on, when a linear equation is given in this kind of form, in this form, what you need to do is what you need to know is the values of m and c can easily be obtained. All right, as you see below. Like now you have, for example, if y equals minus 5x minus 4, then m, being the number beside x, would be what? Minus 5, as you can see in this case, right? Minus 5. And then C would be the number that stands alone, that's -4. Now make sure you take note of the sign. The sign is always going to be there with it. Okay, you don't neglect the sign, always put the sign along with it. All right, now look at, do you remember this one in the notes that I showed you? Another way to explain it, right, where you have a, B, and C as the constants, A standing beside X and B standing beside Y, and then the usual C standing on its own. Okay, and you can then, A is the one standing beside X, which is what, 3, as you can see here, and then B is the one number standing beside Y, which is this sign -2 here. Do you see that now? And then C is the number that stands alone, which is what, -10. Do you see that now? So for you to obtain your M and C in the equation, there is no need to convert. There's no need to convert to the. There's no need for you to convert. Sorry, there is a need for you to convert it to this format so that you know, okay, this is our M, this is our and this is our C rather. Okay. So moving on. And then I showed you a particular example that, okay, for 2x minus y equals 7, right? And then what we did was we made sure that this y comes to the other side of the equal to sign, right? So that by adding y to both sides, or you can just say let's y cross to the other side, and then when y crosses to the other side, when minus y crosses to the other side, it changes from minus y to positive y. Okay, changes from minus y to ordinary y. So then you have y equals 2x plus 7. So now it is in this form here where you have y equals mx plus c. What is going to be our m? The number beside x. And what is the number beside x here? It is what? 2. Do you see that now? Our m is 2 here. And then here our c is the number that stands alone, the constant, which is what? 7. Do you see that now? Our c is what? 7. Can you see that now? And then we looked at equations and tables of values. Now, if you remember this table of values that I gave you in your previous class, you see now this is a table representing a particular equation that you see here. This equation, y equals 2x minus 5, right? It's an equation of x and y. Now the equation connects the two variables x and y so that for every value of x there is a corresponding value for y. Okay, sorry, I forgot to write x here. For every value of x there is a corresponding value for y. Okay, now for example, if x equals 3 then y equals 1, but we are going to be seeing how this is possible when we get to the table. When you see it in the table, you see now the solution is there in the table. How is it possible? And if x is -2, then y will be -9. So the table below shows the values that shows the corresponding values of the variables x and y. That is how the values for x, how they determine the values for y. Okay, all these values for x, how they determine all these values for y. All right, that's what we're going to be looking at on the inside this table now for this particular equation, y equals 2x minus 5. Okay, so we say that y is, now because all the values of x are the ones that determine all the values for y. Remember I told you that this means that y is the dependent variable in this equation, right? It's the dependent variable. Underline dependent variable there inside your note. Underline dependent variable. Okay, and then since this is because the value of y depends on the value of x, so it is the value of x that will determine the value of y in our solution. Okay, and then c is the independent variable, that is the number that does not change. This is our c. the number that stands alone, right? The number that stands alone, no alphabet beside it, it remains the same. It does not change. All right. So that is that about that. Make sure you remember to underline independent, dependent variable, and then C is the independent variable. Okay, good. So now let's look at the table. How do we derive the answers for y? Y is supposed to be equal to 2x minus 5, right? So first of all the values of x now, starting from -2, right? In the question we have mx. What is our mx? Our mx is 2x, right? Y equals mx plus c, right? So our mx is 2x, right? 2x, that is 2 times x. That is what you see here now, right? So 2 times x will be what? 2 times, what is the value of x here? The value of x there is -2. So 2 times -2 to get -4, right? So what do you do then? Then you now do mx according to the question. You see mx minus c here. That is -4 minus 5. -4 minus 5 will give us what? -9. Okay, you are owing 4 naira, you are owing another 5 naira to another person. How much are you owing altogether? You are owing 9 naira, right? Do you see that? That's how it is. Then the same process occurs here as well, as I explained to you in the note. The same thing happens here, the same thing happens here, and here, and here, and here also. You see that in this place also 2x means 2 times x, right? And which is, for in this place the value of x is 4, right? That's why you have 2 times 4 to give you 8. So 8 minus 5, you have 3. Do you see that now? So that's how all the values on this table are gotten. Now we now look at how to plot the graph for this particular table in the next this is the one that I was supposed to teach you today, which is how to plot the points on the table. Now there are some things you need to understand of in the table that we just finished. Now is that now the table contains the following set of ordered pairs of corresponding values. What does this mean? That remember that when x was -2, y was -9. Do you see that now? -2 to -9. The corresponding values for x and y. Do you see that now? -2 to -9. Do you see that now? The same thing when x was -1, x is and y is -7. Do you see that? And so on and so forth. All right, and so on. Now another thing you should take note of is that is part of the properties of the table is that all those ordered pairs that you're looking at when x is -2 and all of these, the values of x and values of y that you get from the value of x, what you need to understand is all the pairs are equivalent to a set of coordinates of points rather that can be plotted on the Cartesian plane. What this means is on the graph that we are going to be drawing, all these points they point to a particular location on those graphs, okay? And then you'll be seeing them when x is -2, y is -9. You see that point right there, okay, as it is plotted on the graph. All right, and then the next one to take note of is, you see this formula y equals 2x minus 5 is a linear equation, right? You all know it's a linear equation which has x and y, the variables x and the variables in a linear equation are always separate and have a power of 1. That is, in a linear equation, all those variables, all those alphabets, you don't see them join them together. they will never be joined together, and then they will not be raised to a power greater than 1. And you know that any number raised to power 1 is equal to the same number, right? If you do GSS 3 raised to power 1 equals to GSS 3. Uncountable raised to power 1 is still uncountable, okay? So GS2 raised to power 1 is still what? GS2. You see now? This means that there is nothing like XY for linear graphs, okay? There's nothing like x raised to power 2 or raised to power 3 or y raised to power 3 or so on or whatever and so on and so forth, okay? There is nothing like that when we talk about linear equation. Everything you do is just straight to the point. There is no raised to power anything. There is no x times y. There is no a times b. All right? It's just x and a whole number, and then c, which is the number that stands on its own without any alphabet beside it. All right? So then next thing to take note of is that the graph of a linear equation is always a straight line, something like that. The line is always a straight line. My lines are curved, don't worry, you see the graph now. And then the last thing is, in general, a straight line has an equation of the form y equals mx plus c. So if you draw your graph, if you plot your graph and it is not a straight line, then it is not this formula. It does not follow this formula. It does not obey this law that linear graph is defined by y equals mx plus c, okay, where x and y are the variables and m and c are the constants, as we have rightly said from the beginning of the class, okay? So now looking at the graph that we plotted, now look at this graph. This is the graph for that table that we saw, right? Now remember that when x was minus 2, y is minus 9. So this is minus 9. Do you see that now? And then the scale here, you can see that the scale here is 1 unit to 1 centimeter to 1 unit. Do you see that now? So on the x-axis, and then on the y-axis we have 2 centimeters to 5 units, or 1 centimeter to 5 units. 2 centimeters to 5 units, sorry, 2 centimeters to 5 units. So 9 would be somewhere here, right? So from 2 up to 9, this is the point here. Do you see that point now? The term is called the point where they meet. Now that's for minus 2 and minus 9. Look at minus 1 and minus 7, where on x-axis is minus 1, on y-axis is minus 7. So where is our minus 1? This is our minus 1, Abby. Going up to this point, we have the minus 7. Do you see that point now? That's the point. And then for 0 is what? Minus 5. As you can see, when x is 0, y is minus 5. And you can see that in the table here. When x is 0, y is minus 5. And the same thing goes on and on and on. You just, when you draw this graph, check your table as well, so you can be confirming all the points, okay? So that this is when x is 1, y is what? Is minus what? Minus 3, I think. And then when x is 2, y is minus 1. Do you see that? Minus 3. Do you see that now? And when x is 3, y is 1. When x is 4, y is what? 3. Do you see that now? That's it. It's as simple as that. There is nothing adding it. All right. So that is that about the graph. You see that in my description here, I said the line is defining y equals 2x minus 5. Do you see that? This is the graph representing the y equals mx plus c. All right. So I hope you learned something today. I hope this was a good understanding for you. So at this point, I'd like to say thank you for watching. Welcome back to school once again. God bless you. I hope you learned something today. I hope it's useful for you. See you in the next class. Okay? Good night.